paleontology team, a group of micropaleontologists, were the keepers of time. We're responsible for providing ages of the cores by looking at the fossils and seeing their appearance and disappearance.
And we mostly work with core catcher samples. So in a way we are the first ones getting results quickly on board. And within the Micropal lab, together with my colleagues Dave and Wenchen, on this expedition we work on diatoms, which are siliceous microfossils.
So I examined the slice of diatoms which was preserved in the sediments, which will give you some information about the age and also the environmental implications of the past. What we do is we prepare from sediments the diatom from different size fractions.
We study organic microfossils of dinoflagellates, like protists in scientific terms, or small microalgae you can think about, and pollen as spore, so remains or fossil of ancient or present vegetation. So basically it's from sediment to acid treatment to sieving through 10 micron sieves and to putting that residue into microscope slides, and then I can go to the microscope and look at the fossil that I found.
These dinoflagellates can tell us a lot of stories, mainly about the environment in which they are lived before they died and sunk to the seafloor, and they are specific indicators for the age of the sediment.
I look specifically at siliceous microfossils, one group of siliceous microfossils which is called radiolarians. Radiolarians are remains of plankton. They're also living in the ocean today, but I look at their fossilized remains. They float in the ocean and they are found at all depths in the water column, from the very surface down to thousands of meters of depth.
Foraminifera are single-celled protists. They've been around for at least 500 million years. Ideally, the critters up here, after they die or they're eaten, they accumulate on the seafloor with the sediments. And so when we core through the sediments and extract a sample, we're able to analyze both organisms at the seafloor and the ones at the surface. The ones at the surface are very useful for telling us about age control. The benthic organisms, on the other hand, are much more useful for telling us about environment.
I work on diatoms, one-celled algae, microfossils, and Antarctica's changed a lot through time. It's been cold, it's been warm, and the microfossils we study are one of the clues that we use to try to figure out what that history was like back millions of years ago.